I wonder, if it costs a bakery $3.50 to make an apple pie and it sells for $12 the first day it's baked, let's just develop this idea. Okay, here's my goal with this problem and with this review in general. What I want you to do is know how to approach these problems. And I want you to approach them in pieces. The first thing you need to do is just take it a piece at a time. And then once you've kind of read through the whole thing, make sure you understand what it's asking. That's the most important thing. If you can make sure you know what it is asking. So, costs the bakery $3.50 to make an apple pie, sells for $12 the first day they're baked. I'm going to stop right here and I'm just going to digest that information before I read any further. If it costs $3.50 to make an apple pie, $12 for if I sell it the first day it's baked. So if I was to make an apple pie and sell it immediately, then I would make how much money? I'm not telling you. I'm going to let you figure that out. That number is going to come in handy later on. If a pie is not sold on the first day, the new price is $8.50. Probability of selling the apple pie on the first day is 75%. It tells me a couple other things. Now we're going to jump down to the actual question. What's the approximate expected profit per pie for the bakery on the sale of its apple pies? This gets into expected value. I don't know if you remember these problems, and I hope you do, but there were some problems that we did where it would say something like, you spin a wheel, and if you land on this, you can win $4, but you paid $5. And you could land on this, and you could get $2, but you paid $5. And we had to figure out the expected value. And the expected value would be negative if you were losing money and positive if you were gaining money on average. And it was that type of problem right there. Okay, I hope that rang a bell. And if it didn't, this is going to start looking familiar in just a minute. But before we get into the actual problem, I do want to just refresh your memory a little bit more. You're at a carnival. I'm not even doing this actual problem. I'm not doing number 12. So just hold on for just a second. You're at a carnival. You're going to spin this 3 equal spaces. You pay $5. You pay $5 to spin this wheel, and here you win $12, and here you win $7, and here you lose. And then the question would say, what's the expected value? What is the expected value? Okay, so here we're going to deal with our probabilities. So the probability, this should start looking really familiar. Probability, if I can spell it, probability, multiplied by what I earn, or what I win, or whatever you want to call it. If I can spell, man, that'd be dangerous. What I earn. The probability that I win $12, well, there's a 1 out of 3 chance that happens. And when I win $12, I really don't win $12. I win 12 minus 5. So I really win, we'll call it 12 minus 5, but we know it's 7. Well, that's not the only thing that can happen. There's a 1 out of 3 chance I could win $7. So 7 minus 5. And then there's a 1 out of 3 chance that I could win negative $5. I would lose everything that I paid, so I have 0 minus 5. Now, the actual answer to this is going to be unimportant. I will tell you it's going to be positive, which means that you should play this game because you're going to win more than you're going to lose on average, and you're going to gain more money. However, this kind of format is going to help us with number 12. So I wanted to refresh your memory with that type of problem before we actually got into it. Now, again, it costs a bakery $3.50 to make apple pies that sell for $12 the first day they're baked. So if I sell it the first day it's baked, how much money do I make? Well, you subtract them and you find it. And once you've subtracted them and you found it, keep in mind the probability that you sell it on the first day. So we're going to go through this problem and find out what happens day by day. So we're going to deal with first day that it's baked. And we'll just take that one little part. Again, let's take this in pieces. What is the probability that I sell this thing on the first day? The first day is 75%, and it's in those little bullet points that are within the problem. So there's a 75% chance that I will sell this on the first day. And when I sell it on the first day, I earn this much money. Which, by the way, the answer to that is $8.50. So there we go. Now we have to keep up with the other things that could happen as well. We may not sell it on the first day. We might not. It might be the second day. If a pie is not sold on the first day, the new price is $8.50. So the second day would be $8.50. Third bullet point. There is a 12% probability of selling it on the second day. All right. So here goes. We're going to have a second day. Second day. There is a 12% chance that that's going to happen. And when it happens, we charge $8.50 for that pie, but it costs us $3.50 to make the pie. Now, we are going to add these things, because, here we go. This could happen, or this could happen, or something else could happen. And every time you see, or every time you say something, and you could put the word or in there, and it's dealing with probability, you put a plus. If it's and, you multiply. Okay, watch this. 75% chance it happens and I make this much money. Or 12% chance it happens and, multiply, I make this much money. Or apple pie does not sell by the end of the second day, it is donated. So first day, second day, and then third day or later. Okay. Now we got to come up with some probabilities on our own, because they didn't give us enough information. Well, they didn't tell us the exact numbers to plug in. They gave us enough information. So what we have is a 75% chance of something happening on the first day and a 12% chance of something happening on the second day. So we need to know what could happen after that. So when we add those two together, we get an 87% chance that something happens here. So what's the probability that it happens here? Well, 87% of the time it happens here, so the rest of the time it happens here. This must be 13% of the time. So this, or 13% of the time, we are going to lose the $3.50 because we donated the pie. And when we donated the pie, we lose the money that we invested in it. Whatever we get when we type that in, that's going to be our answer. Now, again, I'm not going to tell you the answer because at this point, you know how to type. So there you go.